Hello students. Today we are going to study two very important gases, hydrogen and oxygen. Both of them are essential for life and for many industrial processes. We will learn how they are prepared, their main properties, and how they are used. Let us begin with hydrogen. Hydrogen is the first element of the periodic table and also the lightest known gas. It was discovered by the scientist Henry Cavendish in 1766. It is a colorless, odorless, and tasteless gas which is slightly soluble in water. When hydrogen burns in oxygen, it produces water, and therefore its name literally means water former.
Madam, may I ask a question?
Yes, please go ahead.
Why do people call hydrogen the fuel of the future?
Since hydrogen produces a large amount of clean energy when it burns, and the only product is water, it causes no pollution and can replace fossil fuels in many applications. That is why it is called the fuel of the future. In the laboratory, hydrogen is prepared by reacting a metal such as zinc with a dilute acid such as hydrochloric acid. The reaction can be described like this: Zn plus 2HCl gives ZnCl2, and hydrogen gas is released upward. Zinc reacts with the acid and forms zinc chloride while hydrogen gas is liberated. The gas is collected over water because it is almost insoluble in water. In industries, hydrogen is produced on a large scale mainly by two methods. First, the Bosch process. In this process, carbon monoxide reacts with steam to give carbon dioxide and hydrogen. We say CO plus H2O gives CO2 and H2. Second, the electrolysis of water. When electricity passes through acidified water, it decomposes into hydrogen and oxygen. Hydrogen is collected at the cathode and oxygen at the anode. Hydrogen is colorless, odorless, and tasteless. It is about 14 times lighter than air, so it easily rises upward. It is slightly soluble in water and burns with a pale blue flame. Although it burns, it does not support combustion or life. Hydrogen shows some important chemical behaviors. First, combustion. When hydrogen burns in oxygen, it forms water and releases a large amount of heat. We say 2H2 plus O2 gives 2H2O. Second, it acts as a reducing agent. For example, when copper oxide is heated with hydrogen, copper metal is obtained and water is formed. We express this as CuO plus H2 gives Cu and H2O. Third, hydrogen combines with several nonmetals. For instance, with chlorine it gives hydrogen chloride, with nitrogen it forms ammonia, and with carbon it produces methane. These reactions make hydrogen useful in many industries. Hydrogen has a wide range of applications. It is used in the manufacture of ammonia and hydrochloric acid. It is also used to hydrogenate vegetable oils to make margarine or vanaspati. Liquid hydrogen is an important rocket fuel because it releases tremendous energy when it reacts with oxygen. It is used in oxyhydrogen flames for cutting and welding metals and also for reducing metallic oxides to pure metals.
Madam, may I ask one more question?
Sure, go ahead.
Is hydrogen really safe to use as a fuel?
Hydrogen is safe if handled carefully, but it is highly flammable. That means it can catch fire very easily when mixed with air or near sparks. Therefore, strict safety precautions are always followed during storage and use. Now, let us discuss oxygen. Oxygen was discovered by Joseph Priestley and Carl Skeel. It forms about 21% of the Earth's atmosphere and is essential for all living organisms. We breathe oxygen during respiration, and it is also required for burning fuels. In the laboratory, oxygen can be prepared by heating potassium chlorate in the presence of manganese dioxide which works as a catalyst. The reaction is spoken as 2KClO3 gives to KCl and 3O2. The oxygen gas produced is collected over water because it is only slightly soluble.
Madam, what exactly does the catalyst do?
A catalyst simply speeds up the reaction without taking part in it. Manganese dioxide helps potassium chlorate to decompose at a lower temperature, and thus oxygen is released faster. On an industrial scale, oxygen is obtained from liquid air. Air is first cooled and compressed until it becomes a liquid. Then it is allowed to warm slowly. Since nitrogen boils at -196 degrees Celsius and oxygen boils at -183 degrees Celsius, nitrogen vaporizes first, leaving behind pure oxygen. This process is called fractional distillation of liquid air. Oxygen is a colorless and odorless gas. It is slightly soluble in water and supports combustion, but it does not burn itself. Almost all elements combine with oxygen to form oxides. For example, we say 2Mg plus O2 gives 2MgO. Metals usually form basic oxides and nonmetals form acidic oxides. Oxygen also combines with hydrogen to produce water, which is a neutral oxide. Oxygen is used everywhere. It supports breathing, so oxygen cylinders are used in hospitals for patients and by mountaineers and divers. In industries, it is used for steel manufacturing to remove impurities from molten iron. It is also used in rocket propulsion systems as an oxidizer and in water purification to destroy harmful bacteria. Oxygen truly maintains life and energy balance on Earth. So students, today we have studied hydrogen and oxygen, how they are prepared, what their key properties are, and how they are used in daily life and industry. In the next part, we will move on to nitrogen, carbon dioxide, and the concepts of oxidation and reduction. That's all for today. Jai Hind.